You click a button, place bid, send. It feels like magic, right? Like it happens instantly. But in that tiny fraction of a second, your click kicks off an incredible high-speed journey across a hidden global network. And today, we're going to pull back the curtain and show you exactly how it all works. Okay, so take a look at this. This is a map of what happens when you place a bid on eBay. Yeah, I know, right now it just looks like a big, confusing mess of boxes and lines. But stick with me here, because by the end of this, you're not only going to understand exactly what this is, you're going to see the entire internet in a completely new light. So let's set the scene. You're on eBay. You find that thing you've been searching for, and you hit place bid. What actually happens in that split second? Well, we're about to follow that click all the way from your keyboard, across the globe to eBay's servers, and all the way back. But to really appreciate how this is even possible, we need to rewind the clock a little bit. First, let's talk about how things used to be. I want you to imagine a world where all computing was done by one single, giant, powerful brain, a massive computer that had to solve every single problem for every single person, one by one. This was the age of the mainframe. This whole idea is called centralized computing. All the work, all the thinking, it all happened in one central place. And for its time, it was incredible. But you can probably already see the problem, right? It's a huge bottleneck. It's like having one genius librarian for the entire world. Everyone has to stand in a single file line just to ask a question. It's just not very efficient. And this really shows you the difference. On the left, you've got that old mainframe world. Think of each application as a separate tool in a toolbox that literally can't talk to each other. But on the right, that's the new idea, a distributed architecture where everything is connected and can share information and resources. This right here was the total game changer. And this is where the real revolution starts. Someone asked a simple question. Instead of one giant overloaded brain, what if we could connect thousands or even millions of smaller computers and get them all to work together as a team? And that, my friends, is the core idea of a distributed system. It's just a bunch of separate computers, all linked up through a network, all collaborating on the same task. We're not talking about one single genius anymore. We're talking about a massive team of experts all chipping in at the same time. So why is this so much better? Well, for one, you can share everything. Processing power, storage, you name it. Second, it can grow. It's scalable. Need more power? You just add more computers to the team. Third, and this one is absolutely crucial, it's fault tolerant. If one computer in the network goes down, the whole system doesn't crash. The others just pick up the slack. And this all became possible for one simple reason. Computers got a whole lot cheaper. And you know what? You probably have a distributed system in your own house and don't even realize it. Your smart lights, your security camera, your thermostat, they're all separate little computers, right? But they're connected, they collaborate. It's the exact same principle that powers the internet, just on a much, much smaller scale. So, with this new way of thinking, the stage was set for an absolute explosion. The numbers we're about to look at, from the late 90s and early 2000s, are just staggering. They capture the exact moment this idea went from a cool theory to a world-changing force that made things like e-commerce possible. Just look at this. In 1989, there were about 80,000 computers connected to the internet. 10 years later, over 56 million. That is not just growth, that is a supernova. A mind-blowing leap that completely reshaped the world in a single decade. And all that technology changed us, too. It changed how we spent our time. In 1997, the average American spent about 28 hours a year online, a little more than a day. Just 1 year later, that almost tripled to 74 hours. By 2003, it was expected to hit 192 hours. We weren't just visiting the network anymore, we were starting to live on it. And here's the real kicker. The network wasn't just for phone calls anymore. While old-school voice traffic was growing at a steady 10% a year, data traffic, websites, emails, eBay bids, was exploding at an annual rate of 125%. It was a total takeover. The internet was becoming the backbone of everything. Okay, so now we've got the backstory. We understand the technology. Let's get back to our original question and follow that eBay bid. It's time to finally solve this mystery. Hey, remember this? The big blurry diagram from the beginning? Well, here it is, in all its glory. This is the invisible, high-speed road trip your bid takes from your screen to eBay's brain and back again. And yeah, it looks complicated, but it's really just a series of simple, logical steps. Let's break it down fast. 1. You click. 2. Your bid shoots out to your local internet provider. 3. It jumps onto the internet backbone, the superhighway of the web. 4 and 5. It gets to eBay's doorstep and goes through their private networks. 6. It hits one of their many web servers. That's that fault tolerance we talked about. 7. It gets passed to the heavy-duty back-end servers that do the real work. 8. Your bid is instantly recorded in multiple mirrored databases so it can never get lost. 9. The auction is updated for the seller and all the other bidders. And finally, 10. A confirmation zips all the way back across the internet to you. And the craziest part? All of that happens in less time than it takes to blink. So that whole 10-step journey, it perfectly explains the new reality we live in. It's not really about any single machine anymore. The real power is the network itself, the connections between all of them. Now, of course, this system isn't perfect. It gives us this incredible power and reliability, sure, but there are trade-offs. All those connections that make it strong, well, each one is also a potential point of failure. And every new device we connect to the network creates new security worries. It's this constant balancing act between incredible power and new vulnerabilities. And that brings us to this really powerful quote from technologist Tim O'Reilly. The network really is the computer. It's the perfect way to sum all of this up. The machine we're using isn't just the box on our desk or the phone in our hand. It's the entire, sprawling, global web of connected devices that makes one simple click ripple across the entire planet. Which leaves us with one big question. What are we going to build with it next?